On our board today, we are looking at indices and logarithm. So we are starting with indices, and before we look at questions, we need to first understand the laws of indices. So I categorize them into three. So the first one is multiplication law. Now this law states that if we have a number a raised to an index n, and we multiply this by the same number, this number is called base, to an index also n, is the same as maintaining the same base, and we add the indices together. For example, if we have 3 raised to the power of 2, and we multiply this by also 3 raised to the power 4, this is the same as 3 raised to the power of 2 plus 4. And since these ones are numbers, we can sum them together and we have 3 exponent 6. So that is how we apply this rule of multiplication. Now let us move on and take a look at the second rule, and that is the rule of division. Now this law states that if we have also a base a to index n, and this is divided by the same base a to an index n, this is the same as maintaining the same base a, and we subtract the indices n minus n. For example, 3 to the power of 4. If I divide this by 3 to the power of 2, according to this law, I will maintain my 3, and 4 subtracts 2. Now subtracting that, our index would be 2. Now let's move on to the third law. The third law is about the power rule. There are quite many small branches of this law. I'm going to make it one after another. Assuming I have a number a, and this is raised to an index n, then the whole thing is raised to another index n. According to this law, the indices multiplies themselves. So we have n times n, and this comes down to a, the common index, and n. So that is one part of this law. And the next one, maybe we can illustrate using an example here, saying e.g. when we have 3 and this 3 is raised to power 2, again the whole thing is raised to power 3 according to this law. As you can see from here, we have 3 raised to the power of 2 times 3. So 2 times 3 is 6. Therefore, we have 3 exponent 6. And that illustrates the first part of this power rule. Now the next one here is if we have two numbers with different bases, a to the power of m, and this is multiplied by b to the power of n, and again this is to another index p, then this can be categorized the same as distributing p to each of these numbers. So we'll have our a to the power of m, then raised to power p, and we multiply this by b raised to power n, again to the power of p, and it has come back to this rule here that says we multiply all the indices here, and we have a index n, p multiplies b index n, p. So that becomes the rule. So let's move on and take a look at another third one here of power rule still. When we have a, and this a is raised to power 0, this one vanishes down to 1. And keep that in mind, whether it is a letter or a number, like when we have 4 and this 4 is raised to power 0, this is always 1. Then if we have here, maybe say 100 to the power of 0, this is always equals to 1. Whether we have here x to the power of 0 is always equals to what? 1. So this is how this rule states, and still under power rule. And next, assuming we have a raised to a negative index. So how is this treated? Now this negative is the same as 1 over the meaning of this negative, like that, and we have here power a to the power of n. So it means the same thing. So this is the reciprocal. If we have a, then the reciprocal of a is 1 over a. And if our index is negative, then here in the denominator it becomes positive. That is one thing we have to note. Now let's extend this a little bit to two numbers. So assuming I have a, and this a is divided by b, and the whole of this one is raised to an index negative n. So how do you treat that? Now since this one was a reciprocal of a, then we need to get the reciprocal of a over b as b over a. And here the index becomes positive n. So you just need to remember, remove this negative and then switch the denominator and the numerator. So that is another rule, still under power rule. Now let's move on and have another one. If I have a number a, and by the way I'm using a throughout, you can use any letter of your choice is allowed. If we have a raised to power 1 over n, we can treat this as we have our a and we have a root sign, then we bring this number n here. Now if this number is more than 1, then the whole thing will be raised to that number. Now let me categorize this, assuming n is equals to 2. The lowest one is 2. If I have e.g. 1 over my n is 2, and this will be equivalent to the square root of a. For square root, we normally don't write our n, which is 2, here. We ignore it. Let me also look at another one here. Assuming I have, this is example, let's have another example here. If our a is raised to power 1 over 3, where our n is 3, this is the same as cube root of a. And let me move one step further. If I have a raised to the power of, assuming I say 2 over 4. Now this is the same as fourth root. We bring in our 4 and place it here, just like how this rule here suggested, and we have our number a. And here, as I mentioned earlier on, what we have here, if it is more than 1, it will be a power of the whole thing here. And take note also that this one can be the same as fourth root, and we have our a raised to power 2 under the same. So this is the same like what we have here. Now with all this said, these are the most common used rules. So let's go ahead and take a look at some examples. Yeah, so this is our question here, and the first part here, that is part A of the question, says we have 5, and here since we don't have anything here as an index, meaning it is 2 the power of 1, and we multiply this by 5 to the power of 4, and we multiply this by 5 to the power of 2. Then this is the same as maintaining the same base, and since we are multiplying, then we add the indices together. Therefore we'll have 1 plus 4 plus 2. Now when you sum up that, we get 7. Therefore we have 5 exponent 7, and that becomes the solution for the first one. So for part B, we have x square y to the power of 5, and everything is raised to the power of 2, and we have x to the power of negative 1 times y raised to power negative 2, and the whole thing is also raised to negative 4. To simplify this, we need to distribute this power 2 to the two numbers here, and I will split it as x to the power of 2, then raised to power 2. And the next one is y to the power of 5 is also raised to 2. So this is the first part. The second part is here. We have x to the power of negative 1, and we raise this to negative 4, and we move to the next one here, that is y to the power of negative 2, again raised to power negative 4. Now after that, we can simplify this because we have a power rule that says when you have a number raised to a power against another power, these two indices multiplies themselves together. So the first one simplifies to exponent 4, and the next one is y exponent 10, and we move on to the next one. Remember, all these are still what? Multiplication. So if you wish, you can place them like this. Then the next one here, negative and negative multiplies to positive, and we have here exponent 4. Next, that is y raised to the power of 8 positive. Now let's bring the like terms together, x and x, then y and y. Therefore, the first one we have x to the power of 4, then we bring in here x to the power of also 4. To y, we have y to the power of 10 multiplies by y to the power of 8. When we are multiplying, then we add the indices. Therefore, we have here x, 4 plus 4 is 8. We need to show it here that we are adding 4 plus 4 since we are multiplying. Then we will have this y, the same base. We also add the indices. So we have 10 plus 8. Now simplifying, we'll have here x raised to the power 8, and this is multiplied by y raised to the power of 18. Remember, if the letters are brought together, it means multiplication. And since x and y are different bases, then this is where we are ending, and that is how we simplify part B of our question. Let us look at part C, and it's the last part for our video. Here we have 3 exponent 6 divided by 9 exponent 3. So let's copy it down here, and we also get this solution. So part C says 3 exponent 6, 9 exponent 3. So the first thing, we need to rewrite the denominator in terms of 3 such that the numerator remains the same, 3 exponent 6 over, now 9 is the same as 3 square, is also raised to this power 3. So we can move on and simplify still the denominator, and we have 3 exponent 6 over 3 raised to the power of 6. Then we are good to go with the division rule here. Now when I divide the numbers with the same basis, then we do what? We subtract the indices. Therefore we have 3 raised to the power 6 minus 6. Now when we subtract that, we get 0. Therefore 3 raised to the power 0. And there was a rule that says if you have a number raised to the power 0 or a letter, it vanishes down to 1. And this is how we handle indices. If you have watched up to this time here and the video has helped you, thank you for watching, and please subscribe to the channel in order for you to get notification and also to motivate me to do more of this kind of videos. See you in the next video where we're going to discuss more advanced examples on indices. Thank you.